This is Jennifer Miskimmons, SPE trustee to AIME and current AIME president. And I'm here at the SPE Annual Technical Conference and Exhibition in Houston, Texas on October 3rd, 2022 with Mr. George E. King. Mr. King is a registered professional engineer in Texas and Oklahoma with over 50 years upstream oilfield experience since starting with Amoco production research in 1971. His technical background includes basic research on fracture-driven interactions, casing damage during fracturing, energized fracturing production and fracturing chemicals, acidizing asphaltenes, perforating, well integrity and completions, complex formations, unconventional resources, sand control, low-pressure gas well operations, and applications work on coiled tubing, tubing cutoff, formation damage, and well repair operations. Mr. King has published over 100 technical papers, a book on completions and workovers, and multiple book chapters. He has also been an SPE Distinguished Lecturer and chaired numerous conferences. He was inducted as an SPE Distinguished Member in 2015, awarded the Engineer of the Year from the Houston region of Texas Society of Professional Engineers in 2012, received the 2004 Society of Petroleum Engineers Production Operations Award, and also received the Amoco Vice President's Award for Technology from Amoco in 1997. This recording is part of AIME's Oral History Capture Program. So George, tell me about where you grew up.
Okay, I was born in Okmulgee, Oklahoma, and then later moved to Muskogee and graduated from there OSU, and then into Amoco, went to the University of Tulsa to figure out. Now, that's the sequence. Growing up, I don't think I ever have. And my wife would swear to that. But basically, my childhood was very, very interesting because we lived in a very small town, and I spent summers with my grandparents down in a little town called Schulter, Oklahoma. And that is really the foundation of where I really got my curiosity. And if there's one thing that's unique about me, it's I'm curious about just about everything. And I like to dig into it. So I didn't specialize in anything. I was a generalist at the end, but this all came through what I did as a child. And I had a lot of fun growing up, or getting older, I would say. And if you look back at this, you can see how different people and events shaped your life. And that's what I think is unique about a lot of people that really are successful for long periods of time.
So speaking of people that influenced you, you were raised by your mother after your father passed away at a very early age. She had a master's in biology from the University of Oklahoma. So how did her scientific background influence you?
Well, two ways. One, from the time I was born up until the time I left home at about 18 or 19, it was a continuous biology course. I never took biology in high school or college, and I wouldn't take biology under my mother because she would expect me to work a lot harder than I was willing to work. So, but the science was always there, and it didn't take much to really infect me with a passion to develop much more in science, and you can tell by the amount of different topics that you read off, which surprised even me, that I am not a master of everything. I'm simply a jack of all trades and a master of none, but the curiosity carries me through.
So you received a BS in chemistry from Oklahoma State and then went on for a BS in chemical engineering and an MS in petroleum engineering. Who or what influenced you to become an engineer?
My mother will tell you I was born an engineer because from the time I could crawl, she had to really watch me because if I came to something that could be disassembled, I would take it apart. And some of the time I could get it back together again. But that was just the start of things. Now, coming up, who influenced me to go further? Well, my mother was technical on the biological side, but my grandfather, her father, he was born in Italy in 1888, came over with his family in about 1895. He was also developed into a natural mechanic. And there's some people that have that ability to just walk up to something, take it apart, see how it works, fix it, put it back together again. And I guess it's genetic, or maybe it's just familiarization with the person that you're around a lot. But my grandfather was a natural mechanic, as am I, as is my son, and hopefully one of our grandsons will pick it up, or maybe even the granddaughter, I don't know. But this is a little bit of what started me, but the most powerful influences when I got into the industry were George Holman, who was a former area engineer for Amoco in Andrews, Texas. And he was my first boss at Amoco, and he recognized in me that I had ability to talk to people about mechanical things that are in the oil field, pumps, the gears, the equipment, and I could see how they operate. George had been a field engineer with Amoco for quite some time. He knew almost every field foreman that was out there. And so he arranged for me, even though I was based in the research center in Tulsa, I was out in the field chasing well problems at least 1 week a month. And that was better than any college course you will ever take, because you walk into that area that that field foreman knows. You introduce yourself and say, I want to learn about what you're doing, and then listen. And those field foremen taught me more about engineering than any college professor did. And I'm not putting anybody down, but that's where I learned mine. And then as you go even further than that, I count people like Bob Fast and a lot of the different people, Michael Smith, Ken Nolte. You know, these were guys that I worked with in Amoco, and they're just some of the greatest people out there in the engineering field, and I'll never be their equal, but I was always their admirer.
So why did you choose the universities that you chose to go to?
They let me in. Now, that merits a little bit more explanation.
Maybe.
Well, when I was in high school, I had a great chemistry teacher by the name of James Dunn. World War II chemist, worked in the naval research centers, and he wouldn't even tell us half the things he did. But I told him that I wanted to get a degree in chemistry. Well, he said, okay, pick your area. And I said, well, I'd like to go to Oklahoma State, because my mother had gone to OU and my sister had gone to OU, and I just figured, okay, I want to go to somewhere different. So he said, go over there while you're a senior in high school, get an advisor, take the pamphlet of the local junior college or small teachers colleges that were around Muskogee. He said, and see what subjects you can take that will fulfill it without you losing any hours. And I did that, and so I took 2 years where I was driving from Muskogee to Tahlequah, putting 500 miles a week on an old car that I managed to keep going, and working from 2 o'clock till 10 o'clock every day at a sand plant running chemical tests on glass quality sand. All right. When I got over there, everything transferred, but I found out that, boy, going to a university is a whole lot harder than going to a junior college. And that's where my grades kind of went down a little bit, but somehow I managed to go through there. Well, when I got over to Amoco at the end of the summer, they hired me as a lab assistant, the next to the lowest lab assistant grade there was, on the condition I went back to the University of Tulsa, which was local, and get an engineering degree. And so, okay, I took that since I didn't have any other job offers and I was getting married that Saturday. So I went to the University of Tulsa going 3 hours to 6 hours a semester and then 3 hours to 6 hours in the summer. And it took me about 3 years, but I worked my way through and got a chemical engineering bachelor's. But I got interested in, hey, I'm in petroleum, why don't I go a step further? So I applied, and of course my grades weren't good enough to get me into graduate school. But I had one professor that he saw me and he said, why aren't you, I haven't seen your deal for graduate school come through. And I said, well, they told me I'd have to get my grades up to a B, which I had about a 2.8 at the time. And he looked at me and he said, this is Kermit Brown, one of the best early voices in artificial lift. Mm-hmm. And he knew me. Well, he said, don't worry about it, somebody will call you tomorrow. And the head of the department of the graduate school called me and he said, you've been accepted on condition. And so I was in graduate school and I was able to keep my grades up at about a 3.6 all the way through. But Kermit Brown was the enabler for that, and for that I'll always owe him a debt.
It's a pretty good person to have in your court.
Yes.
Yes. Any political or cultural events affect your studies while you were going to school?
Well, the fact that when I went up for my draft examination, they found a small heart murmur, and you know, this was the old-time draft. My draft number was 37 out of 365, so I figured I was gone, and this was in 1971, which we were still in Vietnam. So I went through the whole draft process. You know, those that have been through it, you'll understand. But I got around to the final interview, and that had been an intelligence test and then all kinds of blood tests and everything else under the sun. And every person up there, every young man up there that was coming in had a stack of doctor's excuses. And they took every one of them, every one of those guys that walked in. I had nothing. I just walked in and I said, well, they told me I was born with a heart murmur, that's it. So he listened and he said, that's not much of a heart murmur. And he starts with his pencil and he's over the acceptable, non-acceptable. And you know, this is where you leave almost the next day for boot camp. And then he puts his pencil down and he riffles through the papers and he found the Army intelligence test. And I'd made 99 out of 100, and I would have argued with them about the one I missed, but it isn't the time to do that. Okay, so he sits there with his pencil, and finally, and it seemed like a year, but it was about 5 seconds, and he says literally, oh hell, we don't need you, and checks non-acceptable. Well, I almost turned handsprings after that. No, that's not something I want to do either. So I walk in the next day and George Holman sticks his head out the door and he said, hey, you in the Army? I said, no, sir, they didn't want me. He said, well, in that case, we're going to offer you a job. And that Saturday, Sandy and I got married. And that's been 51 years ago. So that's a political event, if you want to, or a cultural event, or maybe both, if you want to really classify it. But other than that, I thought was very lucky. I may never win the lottery, but I'm okay with that.
I think that's a little bit of winning the lottery, actually.
Probably right.
So you mentioned your GPA. What's your feeling about the emphasis that's put on GPA, and high schools and colleges these days.
Bob Fast summed it up absolutely perfectly. There was 130 applicants for a summer job. I was one of 30 that got picked. At the end of the summer, I was the only one they offered a job. So I finally went back to Bob. I said, Bob, I know I had the worst grades because I had a just a little bit less than a 2.8 when I came in there. And I said, why did you hire me for the summer? And he looked at me with the most quizzical look on his face, shook his head, and he says, I never look at grades. You were an Eagle Scout and you worked your way through college. I figure here's somebody that could actually get a job done. That was what I have said many times, and I have addressed seniors in college. And yes, having good grades will get you in the door, but the education part of it, that pretty well sums it up.
I like that a lot, especially as a college professor. I like that a lot. So you talked about your first job and getting this offer from Amoco. What did you do with that first job? What were the duties?
It was really interesting. They started me off in the acidizing lab. Okay. And I realized that the tests they were running on core etching, etc., the outcome was totally dependent on the way you ran the test, and it really didn't mean a lot. And so I actually got them to scrap that type of testing and really look at field-based testing. Get it out of the lab, get it into the field. And that, to this day, has been my choice of how do you test things. You get it in the field, you get enough instrumentation, and you get the information on it. And if I have any critique of any engineering field, it's that, we're 1 to 5 miles away from what we work with. You can't hear it, you can't touch it, you can't see it, and you don't want to smell or taste it. So what are you left with? It's your imagination of what you can pull together from all of the data that you do have. The rates, the temperatures, the pressures, the type of fluid you're producing, the changes, etc. That's what really makes the educational part of that work. But move it out to the field. That's where we need to be, and that's what we need to check.
So you started working for Amoco in Tulsa. Where else did you work in your career?
I have worked all over the world, well, not all over the world, but in 30 countries, doing either training or solving problems, etc. And that's been on every continent except Antarctica. We haven't found any oil down there yet. But most of the time it's been out of an engineering central district. Now, when I get out to the different operational areas, we'll look at problems, we'll sort through, and hopefully we can find a solution. And I'll talk about the difference between answers and solution a little bit later. But basically what we're doing with that is I'm just using what I can to help the guys that are actually at the coal face, if you will, and working. And I found that I could do that pretty easily from a laboratory or an office, but if you gave me a choice, I'll be right out there in the field looking at the problem.
So you've mentioned some of the mentors in your life. Anybody else, and how overall do you think the mentors helped you in your career?
The lack of mentors can break you. You try to do it yourself. It's not opening doors. It's not getting you opportunities so much as it is making you believe in yourself. And a good mentor will find the things that you do right they'll build on that. They will mention the things that you do wrong, but they don't dwell on them. I'll give you an example. George Holman, again, I'll come back to him time after time. I thought I could really write well coming out of college, so he had me write a report. And this was in the days when if you wanted to send a report to somebody, you had to mail it. This was back in the 70s, early 70s. And I had written a report, and so he knew better than to try to correct it and edit it and all of that himself. So he sends it to Sally Golf, who was an old editor for SPE Journal. And she had retired, and she said, well, send me 2 copies of it. And this is about a 5 or 6 page report, so we sent 2 copies, and she goes through it, sends one back, and it looked like 2 armies had fought to the death in red ink on what I had written. And I'm going, okay, I can't write as well as I can. And then started doing something else. All right. Next thing, George Holman comes in, he says, I think you need to work on your presentation skills. He said, there's a Toastmasters group forming across the street and meeting at a restaurant just right there by Amoco Research. He said, I want you to join that, and I'll go with you and I'll join. And I did that for 5 years, and my presentation abilities went up, they skyrocketed after that. But learning to get your point across in a way that lets people know that you're trying to help them, not criticize them. That is one of the keys to communication, and your ability to listen.
What are some of the biggest technical challenges you experienced in your career?
Okay. This is where we get to solutions and answers. I never look for the answer. I look for a solution. Sometimes looking for a solution, you find the answer. But what we tried to do was to get the wells back online as soon as we could, because that made a lot of difference. Get the back wells working as cheaply as we could, but still stay within the bounds of well integrity. All right. So if you look at all of those things, you come back to how do you really solve a problem? All right. So what I've worked on is foam fracturing. When it very first came out, I rigged up all of the equipment I need and got fluid loss coefficients for foam fracturing and the conditions that impacted the loss from fluid. Later, I've worked on coatings, on what we could put inside tubing and casing that would minimize corrosion. Corrosion is still one of the most damaging problems that we have in the industry. And so coatings, inexpensive coatings, and we ended up lining several wells with different types of liners, etc., and really came to a good solution and started using some of the lined pipe either in place or segmented. When we were just getting into deep water, we started looking at, all right, how long will a sand control completion last? And this is one of the things that kind of characterizes how I approach these. I came up with a template that I could put all of the wells in the field down, which ones failed, when they failed, what type of completion was in there, etc. And I put it just in a spreadsheet. I got a hold of 40 some engineers out there that I talk to on a regular basis, 40 different companies, actually there are more than that, 40 engineers. And I said, take this template, don't put your well name, don't put your company name, don't even put the field name. Put the information on there that we can use. There were no contracts, no lawyers, No money changed hands. This was purely voluntary, and I got 40 companies to send me information. I ended up with 2,200 examples of wells and the data that went with them. And then from that, was able to generate a life expectancy for that type of completion and a reason why it failed. And you have early time failures, which are generally something went wrong in the application, and then a long time period, which you had no problems, and then as they wear, and this is like an automobile, you've got the lemon law to protect you here, you got a warranty here, but when they start canceling the warranty at 3 or 4 years, you better get rid of it because you're going to have a lot of breakdowns and they know it. Same thing is true with this sand control deal. I specialize, as I said, in the weird and the unusual. I like the problems that have no easy solution. So I started working on fracture-driven interactions. A number of people working on those with me, Ali Danashi. We started looking at that. We found a lot of the causes of that and realized it was a multi-cause thing. And it was go back to the geology. Go back to the geomechanics. We got a pretty good handle on that. We're still having them, and I don't think we can really eliminate those. But then we started seeing casing deformations, damage, and occasionally casing failures. And I started working on that and continued to work on that. We put a good little SPE work group together under the Well Integrity banner. So that's what I'm working on right now, and I've worked on this for about the last 3 or 4 years. And these are long-term deals. We found several answers, but not many solutions. So there is a difference there.
There absolutely is. So do you recall any significant experiences working with colleagues that you can share?
Well, there's a few that I can share, but when I broke in 1971 with Amoco, there was still a lot of World War II veterans. And these guys were on the ornery side of life. And they had, some of them had survived combat, some of them had come in just after the war, a few of them had been in Korea. But there's a lot of those things that come in, but there were circumstances, practical jokes, etc., that these World War II guys played on each other that were just so far out there that you couldn't do them today. And everybody just laughed back then. But in terms of working together, I did get the opportunity to work with a number of really successful and really respected engineers that were respected for what they got accomplished, which I think is the way we ought to look at this. It's not the education that you have, either formal or literal, it's what you do with it. You approach a problem, you solve that problem. And so I got to see a lot of those things that were going on. And in fracturing, for example, Mike Smith was really, he came into Amoco and, later fantastic fracturing in NSI, etc. But he was running the downhole television camera at the time. Well, with a downhole television camera, we can see in open hole formations, we can see fractures. And he said, if you read the patent that Amoco had on fracturing, it's on horizontal fractures in vertical wells. And the reason the camera was developed is the patent was running out, and some of the hierarchy in Amoco insisted that it was still horizontal fractures. And so they were going to get another patent or extend this one, and then they found out, well, most fractures are vertical. So anyway, that helped a lot, but we got a lot of useful information out of that as well. So that's just one little thing about these things, but working with George Holman And the field foreman that he knew, I was sent out to work or to observe, and he always called it, just go observe. And there was a job out in West Texas. And I met a field engineer out there, a field foreman rather, and known for being exceptionally successful at getting jobs done. He laid this design out, or the worksheet, and he goes, we're going to do this operation. Now, how can that cause problems? Well, I could get the tool stuck. All right, now where is the tool that'll help me get that out of here? It's here, that's 20 miles away, and this is the best guy to run that. And he had this whole list built up of the problems he could get into, where the equipment was to get him out of that problem, and who was the best at running it. But that is one of the illustrations of working with people. And the field foremen that I met were very good about they had a better idea about what was happening downhole and about what was really producing a problem somewhere than the engineers in the office did, especially the engineers that would not get out to the field and talk to the people. Mm-hmm.
So what milestones in the industry do you think had the biggest impact on the industry?
The biggest milestones that I can tell you are the late 1970s, when they just really closed down on exporting their oil into the United States. And if you looked at that, when I went to work for Amoco, oil was, I think, $2.65 a barrel. Mm-hmm. All right, and then it went up, and oh man, when it reached $8 or $9 a barrel, everybody thought they were in heaven. But really what has been the most, I would say, impactful things that have happened is this cyclic sinusoidal curve of boom, bust, boom, bust, boom, bust. And I wrote an article one time for the petroleum magazine, JPT. It was based on, it's a terrible thing to have a bust. Well, it's not, because you have to slow down and start putting technology to work to help you cut your cost. Because when it's going full blast, you're throwing money at things and you get into problems. But when you get slowed down and your back's to the wall and people are about to get laid off, that's an issue. The other one is we saw in Liberal, Kansas, and another field foreman that I knew quite well out there, he called me up and he said, I want you to come up to a meeting that we're going to have with all of our suppliers. So in this big conference room in the Liberal office, anyway, we were sitting in this room, and the prices were going down, and he puts up on the screen, he said, this is our cost to do a certain job. He said, we have drilled the last well we're going to drill at this price. Now, competitive service vendors, they said, if you want Amoco to drill another well, we've got to get that price down to this. And it was about a 20% reduction, which is significant. Well, after a little bit of pushback, and then, oh, wait a minute, we got to make this work. Because the field foreman, well, they were told, I said, well, we're going to sell it if we can't get the cost down. Well, they didn't want to move. And you talk about being inventive, most inventive people in the oil industry are field foremen. The people that see the problem at the coal face. And I saw that price go down by about 35% over time. But you had one company driving that said, okay, we'll drive the truck this week, and they would haul the parts to all of the different rigs that were running. One delivery was coming out there, not 15 trucks. So you do things like that. When your back's against the wall, you'll be innovative. People will tell you that necessity is the mother of invention. I don't believe that. Desperation is the true mother of invention.
That's a good, very good point, very good saying. When did you first hear about AIME or SPE, and how did your involvement progress over the years?
Again, George Holman. I have to come back to that guy every single time. When I started really getting interested, you know, I said I'd go to University of Tulsa. I did it at night. I worked full-time for Amoco. And he said, okay, you're getting some engineering classes in. It's time for you to join SPE. Well, when your boss tells you that, you join it. But I started seeing the opportunity to be with a bunch of engineers of different companies, and since that time, many of them had become friends, and a lot of them had called me for information when I saw something. If they thought I could help, I'd call them as well. And you get this ring of people coming together, and that's what SPE does. It brings the technology of ability in together and a free talk to different people. And that's why we see so much interest in coming to the specialty meetings and the fall meetings and et cetera. The thing we need more of in the SPE, and I just have to take off on this a little bit, and AIME as well, is we need to talk more about failures. We need to find a way to do that. Now, the corrosion guys do this. They do it beautifully. But SPE, we talk about successes, and the only time we talk about failures is when, yeah, we had a failure, but we've got this thing that fixed it. Well, okay, thing about a failure, first thing you need to figure out, what caused it? And a lot of times we don't. So that's where you have to step back, dig deeper. And what I would really like, if we had meetings like we used to have at Amoco and again at Apache, we called them train wreck sessions. All right, they were closed door. You had to bring your presentation, and generally these are inter-companies, not intra-companies, it's inter-companies. You had to bring your presentation of a failure that you had been part of. And everybody presented, but everybody admitted, hey, we've had a failure. And inside a company, those work beautifully. I'll guarantee you there's more information that changes hands there than any place else.
So how do you see the societies benefiting people in the industry today?
They're giving them a platform to speak, to listen, and to be trained and to train. If you ask me what is one of my favorite things to do, it's train. Now, I come from a line of teachers on one side. My mother, my sister, brother-in-law, we have a lot of teachers. And I told my mother I'd never be a teacher because, dang, guys, you don't make any money. Well, then I got into it, and my mother was ribbing me when she found out that I was doing a lot of training. I said, yeah, Mom, but I make a whole lot more money than a public school teacher does. If you're not training, if you know something, if you really know how to do something, and you're not sharing it, what good are you?
So if you were to recommend SPE to a new graduate, how would you tell him or her about it?
I would tell them that formal training is a very nice thing to have. Literal experience and the experiences you borrow from other people or learn about from other people, that's a gold mine.
So in your opinion, what can we do to attract more young people to the industry these days?
Basically, we have to show them why they need to join. Oil and gas have gotten a little bit of a black eye, well, a lot of a black eye, by people who do not understand energy. We need to educate, starting in the school system, about energy, and then go from there, making sure that people understand that there is difference between a generated energy like electricity that comes from gas and the gas itself, because a lot of people will drive around with license tags on their cars, or bumper stickers bad-mouthing the oil and gas industry, driving an electric car, and then you see them when the hurricane comes through. There's a picture that my wife showed me that was on one of the services the other day. It's this guy with a Tesla at a gasoline station filling up 5-gallon jugs of gasoline to run his generator to charge his Tesla. I love that picture.
What has made working in this field meaningful to you, and what's been your favorite part of working in the oil and gas industry?
I'm a very curious person. I like the camaraderie that we have in the industry. And then I like to work on something and see what I've worked on actually accomplish what I set out to do. It's like the time that I did the sand control study, and they didn't understand really how to program the economics and how long are these sand controls going to last in deep water. Well, I got some information that allowed them to do that, and I've heard that it saved several companies many millions of dollars, tens and probably hundreds of millions of dollars, to have that information and say, okay, let's go to a frac pack rather than just a casing gravel pack. And then there were a lot of other people, David Norman and everybody else that was in that movement at the time, really trying to convince people that we could really do something like this. But the reason why I keep doing it is the challenge. Give me a challenge. Tell me a problem that there's no solution to and that people find impossible, and I will start mentally chewing on that. And I might not be able to solve it, but in some cases I have.
So do you have any regrets regarding the career you chose and where it's taken you, or anything that you wish you could have done differently?
I wish I would have studied harder in school so I wouldn't have to work harder doing it the hard way rather than knowing how to do it the easier way. And as far as regret of the path I've taken, absolutely none whatsoever.
What's your favorite memory or project during your career?
Had to be the Valhall deal. In the 60s, 68, 69, Amoco, or Pan American at the time, drilled 2 wells in what's become the Valhall field. And when they did a flow test on it, the chalk flowed back up the drill pipe, plugged the drill pipe, and they had to to recover 2 wet strings of oil-based mud in the North Atlantic in the Norwegian sector. If you know the environmental aspects of that, even back in the 60s and 70s, you got an idea of, oh man, this is a problem. The oil was there, but the porosity of that rock was 45 to 48% coccolith fragments surrounded by oil. It was simply chalk fragments swimming in a pool of oil. But you couldn't produce the oil without producing the chalk. So again, nobody was really proposing anything, and so I stuck my hand in the air and said, hey, let me try that. I started working on that about 1976, 78. I put together some equipment that, as far as I know, hadn't been built at the time. It was a biaxial cell, not a triaxial, but it allowed me to put pressure on the outside of the core while I was flowing through the core with a movable ram on the end that would push in on the core. And one of the first things I did was duplicate what happened in the field. I pushed chalk into all the flow lines of this equipment, and I spent 2 weeks cleaning it out or just replacing the lines. But okay, wait a minute, I've got something here. And so I started experimenting with screens and things like gravel packs, etc., and finally found out that a pack of 2040 mesh gravel would stop the chalk and let you produce the oil. But when water came through there, you had to change the conditions. So we found a lot of different things and finally found out, okay, we can do this. Well, we did a gravel pack, and sure enough, it would work, but it wasn't really productive enough. This is up into the 80s by the time that we were having this. And so that's when Mike Smith and Ken Nolte and a bunch of people started working on this, and they said, well, let's try a fracture pack. They started this, and were able to get the Valhall field into projection 17 years after the first well was drilled. We started doing horizontal, multi-fracked, tip screen out wells. And we reached peak production, but it took a lot of engineers, a lot of time. Amoco was working on it. The Norwegian segment was working on it. A lot of people working in there, and I made some great friends during that time.
What about your favorite travels? Where's the most fun you've had traveling?
I'd have to say that it was in China, 1985. We went, they just opened to tourists. And so my wife and I, because every time I go somewhere interesting, she wants to go. Now, if I'm headed to somewhere that you never want to go, she'd stayed home. But let me just project a little bit. Put a map of the world out. Put 5 plastic overlays over it. And with each overlay, you color in pestilence. You cover in, it's too darn hot, it's too darn cold, this is a desert, this is a swamp, and you just keep going. And when you're finished, look at the darkest places on the map, and that's where you find oil. Okay, so back to China. So here we go to China, and my wife is a blonde. Comes out of a bottle, but she's a blonde. And another couple, Jim Lee, one of the best guys in artificial lift, and his wife were over there. So we were running around together, just the 4 of us, and his wife, my wife, were blondes. Well, going to China, these people hadn't seen that many blondes. Well, you were supposed to shop at the friendship store. We got tired of shopping the friendship store, so the 4 of us go right down through the Chinese shopping district. All the Chinese around there. Several stories came out of that, but seeing the reaction of the Chinese people, who are just sweet as they could be, with people like my wife and the other lady that was with us, they were just surrounded, and college students, just small groups of college students, would follow them around trying to practice their English with them. But they had so many. I mean, this is a 2 glass of wine story. So we won't go into it here, but guarantee you I loved that. We got to see a lot of the things about China, both the culture, the people, and just really found out that, and this is true wherever we've gone, the people have been wonderful.
So you believe in the quote by Jim Rohn, quote, "A formal education will make you a living, while self-education will make you a fortune," unquote. Can you expand on that a little bit?
You know, I have seen a lot of book smart people coming out with PhDs, et cetera, that knew how to solve the problem, to get an answer. But they couldn't, when they're faced with something that they don't have enough information for, their imagination was not something that would allow them to reach in and unscramble the nest of information that you do get out of these. I taught at University of Tulsa. After I got my master's degree, I taught at night there for 11 years. I taught senior and graduate level course, mostly in well completions, and that Kermit Brown, when he retired, specifically asked for me to teach his course. Now, what I do, and it was an evening course, my tests were never derive the equation. I would give them a folder. Everybody got a 3 or 4 page folder of, this is a field. All right, here's a map of the field. Here are the wells in that field. Here is the water coming in. Here is the geological data that I could have from this. And I'd have 5 problems. There were 40 wells on here. You had this one, this one, this one, and this one. And another person had this one, that one. So didn't worry about them looking on anybody else's test. I mean, man, I had a different problem in each one of those. And I said, okay, what's the problem? How are you going to fix it? And sometimes it was written out. Sometimes you had to do some calculations. But if you had to do calculations, if it required 4 pieces of information, I gave you 3, and you'd have to estimate the 4th one from the other data that was in the equation. And I had people with C averages coming in and making A's. I had people with A averages coming in and flunking because they could not make the connection of what was actually wrong. And sometimes I'd put one in there, didn't have anything wrong with it. And I'd have some build-up tests, I'd have all kinds of stuff in there, but how good are you at really converting that? Well, funny story on that. I had a very good friend, he was from Iran. His folks had to leave when the Shah fell. But he was a field foreman in Iran. At the time, when he came to the U.S., settled near Tulsa, he got his PhD in engineering. A very, very smart, sharp guy. But I was handing a test back one night that I'd graded, and man, they'd done terrible on it. And I said, Ali, what's wrong here? I know they're smarter than that. And he said, it's the way you teach. I'm going, okay, that's interesting. And I said, okay, what do you mean? He says, you got to remember that the experience level of some of the younger people coming into here, if they came from certain families, they've never worked with their hands. They don't know what a J-slot packer is. They don't know how to set things. And so I started going around to the manufacturing places in Tulsa and the area and say, hey, you got a model I can borrow. And I would go in and show them how a J set and unset, how a packer set by just compression, and scores went up. So when you have a failure, you got to figure out what caused it. And that's true in tests as well as it's true in the industry.
What advice would you have for today's young leaders in the engineering profession?
Get out to the field. If you can sit in the office and imagine what's going on, but you'll never know what's going on until you get out to the field, make friends out there. Don't go out there with, got a PhD, or I have a straight, 4-point average. That doesn't impress them at all. Learn from them. I've had plenty of summer students over the years. And I have kind of a thought that if I ever do that again, I'll never hire anybody that has a 4.0 average, because I have problems with them getting the job done. You need to have imagination beyond the book, and you need to be presented with that problem to which the answer is not in the back of the book and the equation has never been written. That is your start of education.
So you stated some personal objectives as follows. 1, always remain curious, unafraid of failure, and willing to learn from it. 2, try to help anyone who calls on you for technical assistance or learning tools. And 3, teach when you can. This is the very best way for you to learn. How and when did you develop these?
I developed you got to make mistakes to learn by making mistakes, because I thought I knew a lot more than I did. And George Holman wouldn't let me forget, okay, wait a minute, what caused that failure? All right. Now, you go from there and you go into the helping people. Like I say, I enjoy training because I learn as much from the students as they learn from me. The questions they will ask, and it's developed one thing about the way I think about things. You've heard the expression, well, I know it, I just can't explain it. If you can't explain it, you don't know it. That's the bottom line on that deal. And what it forced me to do, and I don't learn like most people do, just reading it, I get an idea of what they're talking about, but it doesn't explain it to me. I have to take that apart line by line. It'll take me half a day sometimes to read an SPE paper and truly understand it. And some of them I never do understand because they're just not, well, engineers write and speak in third person boring. It's not a good deal. All right, so you take, as you go through this and you work this out of, okay, this is what they're doing here, I put that on a PowerPoint slide. I put that on a PowerPoint. When I'm finished, I have something that I can show people that don't know any more than I did about it and bring them up to speed a lot faster than I came up to speed. And I have done that since the 1970s. When BP bought Amoco, I took all of my paper, view graphs, and 35 millimeters and took it down to our reprographics department, which Amoco was going to shut down, so everybody was panicked and nobody was sending them anything. I took them everything I had, outspent my budget by probably 20-fold, but I got everything on electronic. Well, nobody ever checks a budget when you're selling a company. It's closing down. They got to pay them anyway. But I've kept all that, and right now I think I have something like 14,000 SPE papers that are in my collection, and I have somewhere in the neighborhood of 15,000 to 17,000 PowerPoint slides in 200 or 300 little modules that I can go through. I've got training modules on every one of those things, and I can put them together, and I love to do it. And you know, if somebody like a college professor asks me, say, hey, can you help me get this course started? I'll send them 500 or 600 slides and say, okay, if you need more here, yeah, download it from this point. And I don't charge anything for that. I mean, I'm just passing information along.
I'm sure people appreciate that very much.
They have expressed that, yes.
Yes. So George, is there anything else you'd like to discuss or share?
Well, understanding that you're from the Casper, Wyoming area, I do have one. In the early 1990s, late 80s, early 90s, we were developing gas fields up in Wyoming, Utah, and Anschutz Ranch being one of them. And we started having problems with completions. We could not break the completions down to just do a cleanup on it because we weren't fracturing them yet. We were going to wait to fracture until we blew some of the condensate down and then blow the gas down. But it was the largest nitrogen injection project in the world at that time to just keep pressure up. Well, we started having problems with completions that we had not had problems with before. So again, we had nobody to tackle that, so they said, hey, try this one. And so I had made some friends up there and called the perforating company and said, hey, let's do some test shooting. And so we went up to the Casper City dump and poured 30 4-foot diameter culverts full of cement with casing down through the middle of it. Different sizes of casing. We had some dual strings. We had all kinds of things. And then we got all of the perforating companies that were supplying charges and had them load some guns, come out there and test. And we did find some problems with one company's charges, that they were a little bit off center when they were being constructed, and so we weren't getting good penetration. So we found the solution to that, but we had a lot of fun shooting guns off in the Casper City dump. Some of these guns, and they were all sizes of guns from 4-inch guns down to the 2 and 3/8-inch guns. And as these smaller guns would shoot, the recoil off of this would blow these guns in the air. We launched perforating guns about 70 feet in the air at times. Now, I'm glad Asha was not on site for this, but this was a field test that actually very, very successful at demonstrating, finding the problem, finding the cause of the problem, and then demonstrating how we were going to do this. And afterwards, with a lot of debris left in the Casper City dump, that probably if anybody dug this up, an archaeologist later, they're going to wonder, what in the world? You might have had a world war right here or something. But nonetheless, nobody in Casper minded too much, evidently, because we didn't hear anything negative about it. But we solved the problem by doing the field work instead of just trying to figure it out in a laboratory. And I guess that's a good end.
That's a great story, and as a Wyoming kid, yes, I very much appreciate that. So truly, what a fascinating career and life you've had, and it's been a pleasure to spend this time with you. So thank you again very much for your willingness to share your story with AIME.
And thank you very much for being interested enough to listen.
My pleasure.